Hello everyone, my name is Shafi. Today in this class we are going to discuss about OSPF. Okay, before we get into OSPF, what exactly OSPF and how it works and how we can configure this OSPF. So if you remember in the last class we have discussed about the routing and we have implemented the static and default routing. The lab we have done this one. Okay, in a routing we have two types. One is the static routing, another one is the dynamic routing. So static routing, what is static routing, how it works, how you can configure, which we have already discussed and done the lab also here, this one. So, but today we are going to discuss about the dynamic routing. Okay. What is this dynamic routing? How exact? Okay. That's what we'll be discussing here. See, when you have a topology like this, so I'm going to give the topology, like similarly how the in the static lab, how the lab topology was there. Similar lab I'm taking here also. Okay, see, for example, I'm having one router which is connected to the switch. Consider this is your 10.0 network. Then router to router, it's a serial connection. It's a 20.0 network and another local network which is having the 30.0 network here. Suppose you want to communicate from 10.0 network to 30.0 network, it's not possible by default. Why? Because so in the routing table, it will be having the information of 10.0 network and 20.0 network. There is no information of the 30.0 network. So that's the reason you have to implement the routing. That's a static routing. How? So statically, if you implement means adding the destination information to the its routing table. That's how it will be working the static routing. But coming to the dynamic routing, what happened here? We use protocols. We use what? Protocols here. See, the same topology I'm having 10.0, 30.0, 20.0, this one. Okay. Now I'm not adding the destination information to its routing table. Okay. Just I'm implementing the protocol here. Okay. Example OSPF protocol. I'm configuring the OSPF protocol here also. And I'm configuring the OSPF protocol here also. In the both the router, I'm going to configure OSPF protocol. The moment I configure OSPF protocol, automatically this protocol, they form the neighbor relationship and they'll exchange the information automatically. Okay, boss, I'm having the 20.0 and 30.0 network. If you want, you take it. Now router 1 tells, even I know the 20.0 network, but I don't know 30. Yes, I'm going to take 30.0 network. Now I know 30.0 through OSPF. Okay. Now again, this router is going to publish. Okay, boss, I have 10.0 network, 20.0 network. You want, you take it this information. Even router 2 tells, even I am aware about the 20.0 network, but I don't know 10.0. Yes, I'm going to take 10.0, this one. See, automatically it form the neighbor relationship. Automatically they'll exchange the information. That's how the dynamic routing works. So here we have a different protocol. Example, we have RIP protocol, EHRP protocol, and OSPF protocol. Okay, these are the three protocols comes RIP, EHRP, and OSPF. But today we are going to discuss about OSPF protocol, not this RIP and EHRP here, this one. Got it? Okay. Now let's see that how exactly, what is this OSPF protocol, how it works, and also we see the lab here, this one. Okay. This OSPF protocol is developed by this guy, Dijkstra. And it was developed by Dijkstra algorithm actually. Okay. There is an algorithm. Based on that algorithm, this OSPF protocol was developed. Okay. And what is the Dijkstra algorithm? That's the name of the person who, invented that Dijkstra algorithm, that one. Okay. That is what Dijkstra algorithm we have. Okay. And this is the guy, the Dijkstra. Okay. Who is actually he found the Dijkstra algorithm. From there, they have developed the OSPF protocol, this one. Okay, this one. OSPF stands for Open Shortest Path First. It is a link state routing protocol. It is an open standard protocol. Open standard means what happened? You take any vendor router, you can implement the OSPF protocol. For example, you have Cisco router, HP router, Nortel router, or any other router you take, still you can able to be implement the OSPF protocol because of it's a industry standard. Okay. Next, the port number of this OSPF protocol is 89. Every protocol will be having the port numbers. Okay, the protocol, it is identified by the user, but in networking, actual communication happens or devices will be understand based on the port number here, this one. So OSPF stands for Open Shortest Path First. It is an industry standard protocol. Okay, and the port number of this OSPF is 89. And some of the features we have here, this one. So one is the link state routing protocol. Actually, in a dynamic routing, we have three types. It's classified into three types. Okay, link state is the one. Distance vector, link state. This is a hybrid protocol we have, right? Now OSPF comes under the link state routing protocol. That is the one we have. Next, it's an open standard. Open standard means you take any vendor router, you can implement the OSPF protocol. And it was derived from the Dijkstra algorithm. Means it was developed, the OSPF protocol design or developed or derived from the Dijkstra algorithm. Okay. Next, it is a classless protocol. It is a classless. If you remember, in a subnetting, how many types of subnetting we have? I am not asking how many classes we have. How many types of subnetting we have? Or how many methods available to do the subnetting?
So two types,
There are two types. Which are those?
FLSM and VLSM.
FLSM and VLSM. FLSM means, okay, class full. FLSM means what? Class full. VLSM means class less. Okay. Now, this OSPF is a classless protocol. Classless means what? VLSM. That means if any protocol supports the VLSM, that protocol also support for FLSM. Getting my point? You have the DVD. Of course, you can play the DVD. In the same DVD, CD also you can play. Right? It's a DVD player. DVD you can play it. Disc you can play. If you have a CD disc also, you can play it on that one. That's how classless. Classless means it's a supports VLSM. Also, it supports FLSM. If it is a class full, then it supports only FLSM. That means there is one protocol, RIP protocol is there, right? RIP is the class full protocol. Class full protocol means whenever you do the subnetting, if you have done with the FLSM, then only it supports. If you have divided your network with a VLSM, then RIP protocol doesn't support. On the RIP protocol, whenever you want to implement the RIP protocol in any router, your network is divided or if your network is subnetted with a VLSM, then it doesn't support. Got it? That is what classless and class full. Okay, classless means VLSM. If it is a supporting VLSM, it also support to the FLSM here. See, that is what the next point we have. Supports FLSM, VLSM, CIDR, manual summary, every type of subnetting, whatever the subnetting you have in the IP address subnetting, it supports everything because it's a classless routing protocol. Okay, it does the incremental update. Hello timer is 10 seconds, dead timer is 40 seconds, and always it does the incremental update. What is this incremental update means? For an example, I'm having a topology, this one. This is my router 1. It's having 1.0 network. From the router 1, I'm connecting to the router 2. I'm having 2.0 network between the router 1 to router 2. And in the router 2, locally we have 3.0 network. Okay. Now I'm in the both the routers, I'm implementing the routing protocol. So the moment I implement the routing protocol, first this both the router, they form the neighbor relationship. They form what? Neighbor relationship. After forming the neighbor relationship, they will exchange the information. What information router 1 having, what information router 2 having. This is how they'll be exchange that one. Okay. So for an example, when the first day I'm giving the class, I'll introduce myself, right? Okay, what's my name, my experience, my technology, everything. Similarly here, to form the neighbor relationship, they'll exchange their information. Whenever to introduce yourself, for example, router 1 is introducing to the router 2. So it will be introducing by its name and what information it's having and everything, that one. Okay, that's over. So same time router 2 also will be introduced and they'll be exchanging. After that, they'll exchange the information, whatever the information they have. After that, what happened? Suppose they form the neighbor relationship, they exchange the information. After some time, if this router 2 goes down, what happened? Now already I got 3.0 network information with the OSPF protocol. Now in the router 1, in the routing table, it knows the 3.0 network to the routing table. How we got it? From the router 2 I got it. Okay. Now after some time router 2 is down. Then router 2 is down, but someone is trying to communicate to 3.0 network. The traffic comes and it is going to hit to the router. In the router, it check the routing table. Yes, I know the 3.0 network via OSPF protocol. Then it's going to be send the traffic to from router 1 to router 2. But actually router 2 is down. Then it's not possible to communicate, right? When it is not possible to communicate, what happen? Packet drops. But unnecessary, this router 1 is processing the traffic, right? Simply taking everything this one. So that's the reason what happened. Whenever you implement the routing protocol, okay, after they exchange the, after they introduce themselves and exchange their information, every few seconds they send the hello packet. Even successfully establish the neighbor relationship, every few seconds they'll exchange the hello packet. Example, okay. First day I'm giving my complete introduction. Next day I'm coming, I'm hey, hi, hello. That's it. Next day I'm coming, I'm greeting with hey, hi, hello. That's it. So here also what happened? Every few seconds they exchange the hello packet. So that is what hello timer is 10 seconds. That means every 10 seconds they'll send the hello packet. Why? Because to know other router is alive or not, other network is alive or not. Okay. So every 10 seconds what happen? It will be exchange the hello packet. Hello packet means small packet. Okay. Suppose the router 1 is sending the hello packet, router 2 is going to acknowledge to that packet, small packet. So for example, if I say hi, miss, you also saying hi, right? That is what you are acknowledging to my hi. So that's how hello packet will be sending. Now dead timer is 40 seconds. That means first I am sending the hello packet. I'm not getting any response. I'll wait for another 10 seconds. Again, another 10 seconds, I'm sending hello packet. Not getting any response. 20 over. Again, I'm sending hello packet. Waiting. I'm not getting response. Again, I'm sending hello packet. So 40 second over. Within 40 seconds, if I'm not getting any reply, then I'll consider that one, the other network is not available. Even from my routing table, I'm going to be flushed this information. Whatever the information I have learned or I got from the other router, all that information I am going to be flushed from the routing table, that one. So that is what dead timer. That is what routing protocol, right? Suppose you want to do it everything manually, then what is the use of dynamic protocol? Got it? Hello timer and dead timer. So that is what the hello timer and dead timer. Every 10 seconds it sends the hello packet. 40 seconds is means within whenever it's sending the hello packet, for every hello packet it get the acknowledgement. So if it is not getting any acknowledgement for that one, it will wait for the 40 second. Within the 40 second, if it is not getting any acknowledgement, then it will be flush the all the information from its routing table, whatever it's learned from the other router. Clear? That is what hello timer and dead timer. So there is a one more thing we have here. It does incremental update. Can you see this one? It does incremental update. Incremental update means what? First time when it is a forming the neighbor relationship, complete information they'll exchange. For example, first day I'm taking the class, I'm introducing, I'm giving my name, my experience, my technology and everything. Same time you will be introducing yourself. Okay, so how you got to know about my training and how you got to know about this place and what's your qualification, what's your experience and everything you all be exchanging. But the same thing we are not doing every day. Is it we are doing every day that one? Again, next day also I'm coming, I'm giving my introduction and you are giving your introduction. you'll be not giving that one. So here, first time they exchange the complete information, and the second time only incremental. Incremental means if it is done any changes. Example, when they form the neighbor relationship, only 10.0 network was there. After forming the neighbor relationship, we are adding one more network into the router one. That is a 40.0 network, 4.0. Okay. Now router 1 is going to update this 4.0 network, or else it send only hi, hello. Okay. So whenever it is communicating to the router to hello packet, it also update the 4.0 network. Boss, we have the one more new network, 4.0 network is added. If you want, you take it this information. That is what increment. Increment means something, the changes happen here, that one. Or tomorrow what we are doing, after few days, again we are removing this network, 4.0 network. Again it's going to update. Boss, the 4.0 network we have removed from my network. Please remove that 4.0 network even from your routing table. That is called incremental update. Means only the first time they'll exchange the complete information. But every time, okay, just send the hello packet. If there is any changes happen, then only it's going to be update to the other router. Means first day I'm giving my introduction, from the next day I'm giving only the hi hello, that one. Suppose if I have done the new course, I have done new certification, then I'm going to update. Hey, hi guys, yesterday I have given some AWS training, AWS certification, which I have passed out on that one. That's my new update. When the first day when I have given my introduction, I have not written my AWS certification. So after few days, I have written my AWS certification. That information I am exchanging. That is called increment. Something changes here, this one. But RIP protocol, it does complete, not increment, full update. Means full update means every day I'm coming and giving my introduction. Like every time when it is sending the hello packet, right? It will not send normal hello packet. Complete update is going to be update. Like every day I'm coming, I'm giving my introduction. After that, I'll starting the class. That's how RIP protocol works. But here it does incremental update. Only first time it will be exchange the complete information. The next time, if there is any changes happen into that network with respect to the OSPF protocol, only that information is going to update. The other information is not going to update anything on that one. Okay. So the next is the multicast IP address. Okay. Multicast IP address of OSPF is 224.0.0.5 and 224.0.0.6. Okay. All the routing protocol, it works based on the multicast communication. What is this multicast and what is this IP address? Yes, multicast means one to many. Okay, so the multicast. What is this multicast and why it use multicast IP address and how exactly communication happens when you have implemented the routing protocol on the routers? So that's we are going to be discuss here in this one. Okay, for an example, I have one router. This is my router, which is connected to multiple routers. So this is my router one connected to multiple routers. So this end, I'm implementing OSPF protocol. Okay. Then here also I'm having OSPF protocol. Here I have RIP protocol, RIP, and here I have the EHRP protocol implemented. Okay. This router one is connected to 3 different routers, but other end we have different protocol. Here EHRP is implemented, here RIP protocol is implemented, then here OSPF protocol is implemented. Now I can form the neighbor relationship only with these two, router 2. Consider this is my router 2, this is router 3, and this is router 4. Okay. Now router 1 form the neighbor relationship only with the router 2, because router 1 also we have OSPF protocol, and router 2 also we have the OSPF protocol. But I will not form the neighbor relationship with router 3 and router 4. I will not form because the other end different protocol we have. Whenever to form the neighbor relationship, both the end it should have same protocol. Okay. Sorry guys. If it is a different protocol, it's not possible to form the neighbor relationship by default. Yes, we have the other option, that one, but by default it's not possible, that one. Okay. Now how router understand that one? Other end it's implemented same protocol. See, in your router OSPF is implemented. Okay. Then how the router one understand that one? Router 2 implemented OSPF, router 3 is router 3 and router 4 is implemented some other protocol. How it understands? It's not a human being, right? Then how routers understands? Yeah, send something, collect. How exactly that? So whenever you implement OSPF protocol, okay, whatever the information, if it wants to send or exchange, it exchange with its multicast IP address. It exchange with its multicast IP address. What is my multicast IP address? 224.0.0.5 and 224.0.0.6 here. Okay. Every routing protocol having its own multicast IP address. Every routing protocol having its own multicast. Example, see, now I am not aware router 2 what protocol is implemented, router 3 and router 4 whatever. Since I have connected to all the three routers directly, I am sending the neighbor relationship. I am trying to form the neighbor relationship with all the three routers. Now I am sending my information, my OSPF information by using this IP address. Okay, 224.0.0.5 for an example. I am sending. Now other end also it using the same protocol and same number, same IP address. It sends yes 224.0.0.5. Even I am 224.0.0.5. When it is coming to the RIP here, RIP doesn't support multicast. RIP supports broadcast. Whenever if the RIP wants to be sent any information, always it's sent through broadcast. Example, 255.255.255.255. So now my IP address is what? 224.0.0.5. Your IP address is what? 255.255.255. IP address is not matching, right? Okay, I'm sending, it looking, and it's not going to respond anything, that one. At the same time, EHRP. EHRP tells my IP address is 224.0.0.10, but you're the 5, not matching. When it is not matching, it's not going to respond anything. It receives. Okay. Router 4 also received, but it's not responding. Router 3 also received, but it's not responding. But only router 2 is responding. Why? Because other end also OSPF. So here also I'm having the same multicast IP address, this one. That's how whenever you implement any routing protocol, when the routing protocol, they want to send any hello packet or they want to exchange any information or they want to form the neighbor relationship, always they use the multicast IP address. And this multicast IP address 224.0.0.5 and 224.0.0.6, it's reserved only for OSPF. No other protocol can use this IP address. Okay, 224.0.0.5 and 224.0.0.6, it's reserved for OSPF protocol. Got it? That's all. Like example, I am the router. For everyone I have connected. Okay. Now I will speak in Telugu. If I speak in Telugu, everyone can hear, right? Yes or no? Everyone can hear. But only those who knows Telugu, only they can reply to me. They can respond to me. Other people will not respond, but still they can hear and they will not respond. Similarly here, When the OSPF sending, it receives here, but it will not respond anything that one. Why? Because I don't know that one. That's how the routing protocol works. Got it now? What is multicast IP address? You remember class A, B, C, D we have. A, B, C, we have a control where we can do the routing. Class D is reserved for the multicast. This is how it's reserved for the multicast. So now you got it one IP address, two IP addresses that uses for OSPF. Another 224.0.0.10 also it used for the EHRP protocol. This is how for different protocol in networking. So it used multicast communication. It's got reserved already that one. It's not possible to change that one. So that is what the multicast IP address. Clear? Next, the metric is cost. Cost is equal to 10 bar 8 slash bandwidth in Mbps. When you have multiple paths, for example, this is my router 1. I am connecting to router 2. From here, another router, router 3. Then finally, another router we have. Then I am having router 4. Then here I am having. So this is my router 8, router 2. This is router 3. This is router 4. Example, router 1 is the source. Router 8 is the destination. To reach from the router 1 to router 8, how many paths available? There are 3 paths available. Via router 2 I can reach, via router 3, via router 4 I can reach here, this one. Now, when you have a multiple path to reach the destination, now routing protocol, it selects best path. It selects what? Best, which is my best path to reach the destination. Okay. Now here, how it will be selecting the best path? Based on the metric. Based on the metric. Every routing protocol having its own metric. Metric means its own calculation to select the best path. So here, the metric is cost. The metric is what? Cost. Actually, there is a formula how to find the. This is a cost is equal to 10 bar 8 slash bandwidth. So some number you're getting here, this one. Okay. That's how we have the metric calculation. Means, suppose you have high speed bandwidth. The number comes what? Lower number, right? Okay. Example here. This is 1 Mbps speed. 1 Mbps speed. 1 Mbps speed. 1 Mbps speed. 1 Mbps. Mbps I'm taking. Okay. 1 Mbps speed I'm taking. Here I'm taking 1 Mbps here also. But here I'm taking 10, 5, 2, 1. That means Mbps. Via router 2, if I communicate, speed is 3 Mbps. Via router 3, if I communicate, speed is 2 Mbps. Via router 4, if I communicate, 18 Mbps. If I divide that 10 bar 8 slash this one, something, okay. So what happened here? The smaller amount, something here, I'm taking some number I'm taking, 216, something number I'm taking, okay, random here. So here I'm taking 180. Here number I'll get 97. The more bandwidth, more number we have, the lower number we get it, right? Okay. So 216, 180, 90 something, something value we get it. This value is the cost. Cost is equal to 216, cost is equal to 180, cost is equal to 97 with this one. Which is the lowest number here? 97 is the lowest number. So that is my best path. Who is 97? Via router 4. So it will be selecting this as my best path. It will not look in between how many routers are there, how many hops are there, it will not look. So always I'll be look for my metric is cost. But RIP protocol, the metric is hop count. means how many hops are there. Example, here, if I am using a routing protocol, via router 2, how many hops we have? Mm, 3 hops we have. From here to here is the 1, 2, 3. Via router 3, 1, 2. Via router 4, 1, 2, 3, 4. 4. Now, which is the lowest number? 2. If I am using RIP protocol, RIP will be selecting this as the best path because it will be calculating metric as a hop count. Okay. So everyone will calculate different things. But OSPF is the metric is cost. Which path is getting the very good cost, means lowest cost. That is my best path. Got it? So that's how this it will be selecting the best path. Got it? What is metric means what? Why it uses the metric? Okay, that's how the metric we have this one. So the next we have, okay, AD value 110. Example, I have 2 routers. In both the protocol we have implemented. So for example, this is how we have 1.0, 2.0 and 3.0 we have. In both the router I have implemented OSPF and also I have implemented EHRP. Here also I have implemented OSPF protocol, EHRP, and there is no condition that one router, only one routing. So one router, multiple protocol we can implement. Now, how many protocols we have implemented? 2, OSPF and EHRP. Now, which protocol it uses for communication? It will not use both the protocol. It has to use only one protocol. Which protocol it is going to use to communicate? It uses OSPF or EHRP. Anyhow, it has to use one protocol, either OSPF or EHRP. It can't use both the protocol. Why OSPF? Okay, the AD value of OSPF is 110. AD value of EHRP is 90. Which is the lowest number? So it use EHRP protocol. That is what AD value. When we use AD value, administrative distance, suppose if you are running a multiple protocol on both the end, okay, now it has to be decided which protocol it has to be used to communicate. In that scenario, it will be looked the AD value. Okay, who is having the less AD value, that is the best. Got it? So that's what here. AD value. Next is it does load balancing via 4 equal cost path. What is this equal cost, unequal cost? It doesn't support unequal cost. Okay, equal cost means I want to communicate source to destination. I am having multiple paths to reach the destination. I'm having multiple paths. 3 paths I'm having to reach. Suppose if the 2 paths getting the same metric, the metric here also 10 and metric here also 10. It select the metric, right? Okay. And here metric is 20, which is the lowest number? 10. So, but 2 paths having the same metric. Then which one it will be selecting as the best path? To reach source to destination, if you have a multiple path, it will be selecting only one path as the best path. Now, which path it is going to be selected as the best path? Not hop. My metric is cost. So, for example, the cost I got it 20, 10, 10. One we got 20, another 2 we got it 10, 10. Okay, leave it about the 20. So 10, 10 we have this one. If it is a single, I'll be, but 2 different paths having the same metric. So it does equal cost load balancing. That means 50% of the traffic it sent here, 50% it sent. Like this, maximum it support 4 paths. Load balancing via 4 equal path. Okay, suppose 4 paths I'm having 25, 25, 25, 25% it will be sending here. Same metric. If it is multiple paths having the same metric, means all the 4 paths are best. Then 25 it will send here, 25 here, 25 here, this one. So that is what this one. And hierarchical network design using area. Okay, so OSPF, whenever you implement OSPF, so without area it's not possible to implement OSPF. It's a mandatory, the area we have to be configured. There are multiple areas. We have this one. Area 0 is the backbone area. Without area 0 it's not possible again to implement. Area 0 is the default area also, and it is also a backbone area here, this one. Now, I'm not explaining about what is the area, how many types of area, and how area works and everything. Why? Because that is a completely networking. See here, I'm just giving only the introduction and brief idea about what is the protocols, how it works and everything. Because that's not that much important, because you'll be not working all these things. But still you should have the idea here, this one, where if you are the network engineer, then you should have complete knowledge here. Got it? So that's how the OSPF protocol, we have this one. Next we'll go and we'll be implement the OSPF protocol, and we'll see that one, how that OSPF protocol works, and how you can configure and everything, how many different types of table, everything it supports. Clear? Any doubts, any questions? Okay, the practicals we'll do tomorrow. Before we wind up, you have any doubts, any questions?